So today we're going to talk about significant figures, and this is a hard topic for chemistry students. So I'm first going to explain the importance of significant figures, and then the rules, and then we'll do some practice problems. So the importance of significant figures is this. It says right here, a measurement can only be as accurate and precise as the instrument that produces it. So let's scroll up just a little bit and look at a couple of these thermometers and talk about what that means, what this, a measurement can only be as accurate and precise as the instrument that produces it. So if we look at this thermometer right here and we were to determine what the temperature is, we would first need to decide what increments the measurements are being taken place in. So between this 0 and this 10 is where our line is, where our temperature is. And I also notice that there's not 10 marks in between this 0 and 10. So that means that the measurement must be taken in something other than ones. So for example, this line right here is not 1 degree. So let's figure out what it must be. If we know there's 1, 2, 3, 4, 5 marks between 0 and 10, we know these lines must be representing 2's. So for example, this must be 2, 4, 6, 8, and then that top one that's labeled 10 is representing 10. So I see my line being right here. So I would say the temperature of this would be 8. But the thing about taking measurements is the last digit always has to be an estimate. And since I feel like it looks pretty close to being right on the 8, I'm going to say it's 8.0. So let's go on to this next one. I see on this one, the temperature is between -10 and -15. So these marks must mean -11, -12, -13, and -14. So I would say that the temperature is between -11 and -12. So since there's not a mark in between there, I can't say that the temperature is -11.55 because I don't even know if this 5 is right, let alone this 5. So that's where significant figures comes into play. Where this says a measurement can only be as accurate and precise as the instrument it produces is exactly what this means up here. So let's go on and talk about some rules. Our first rule here is all digits 1 through 9 inclusive are significant. So basically what that means is any number that is not a 0 is considered significant. So here we have a 1, a 2, and a 9. None of those are zeros. So this number, 129, has 3 significant digits in it. Let's scroll down and look at another example of that. Oop, here's a good one. As we can see, the 6, the 9, and the 5 are all digits, are all rule number 1. They are all non-zero digits. So I would say that this number 3, 699.5, has 4 significant digits. Okay, let's look at rule number 2. Zeros between significant digits are always significant. I call those trapped or sandwiched zeros. So for example, this is a non-zero, and this is a non-zero. So they are both significant. Now these zeros inside those non-zeros, the trapped or sandwich zeros, are now considered significant. So we have a total of 1, 2, 3, 4 significant figures. So let's scroll down and get an example of that. Oh, here's one. Rule number 2. Rule 2 says the 5 and the 1 are significant because they're non-zeros. And then the 0 in the middle is significant because it's trapped. So this number 3 has 3 significant digits. So now let's look at rule number 3. Trailing zeros in a number are significant only if the number contains a decimal point. A point that they, or a little note in here that they don't add is the zeros must be trailing a non-zero. So that's a very important tip, or a very important part of rule number 3, is that trailing zeros in a number are significant only if the number contains a decimal point. So let's look at this. Let's look at this one down here, and it shows that the number 100 only has 1 significant digit. And that is because there is no decimal in this number. But see right here, when we add the decimal, now only the 1 is not significant. We have 1, 2, 3, 4 significant digits. So that decimal makes all of those zeros significant because those zeros are trailing a non-zero. Okay, let's look at a couple examples of this one because this one's kind of confusing. Let's look at number 4. So on number 4, we know the 5 and the 1 are significant because of rule number 1. We know the 0, the trapped 0, is significant because of rule number 2. And now we know this 0, this trailing 0, see it's trailing behind the non-zero. The trailing 0 is significant because of this decimal right here. So now we know there's 1, 2, 3, 4 significant digits. All right, so let's look at number 4. Number 4 says zeros in the beginning of a number, So we call that leading zeros. Zeros in the beginning of a number whose only function is to place the decimal point are not significant. Not significant. So that means any zero before a non-zero are not significant. Leading zeros are not significant. So this isn't significant, this isn't significant, this isn't significant, but of course the 2 and the 5 are because they're non-zeros. So this number has 2 significant figures. So let's look at number 1. These 2 zeros are leading zeros, not significant, which leads that 2 to be 1 significant digit. How about number 2? We've got 2 leading zeros, not significant. we've got a non-zero, definitely significant, and we've got a trailing zero, and we know from rule number 3 that trailing zeros are significant. So we have 2 significant. Let's see, let's do number 6. So this non-zero is significant, and these zeros are trailing, and there's a decimal, always important. So there's 1, 2, 3, 4 significant figures. Let's see, let's find a tricky. All right, how about this one? We know the 8 and the 4 are significant because they're non-zeros. We know the 0 in the middle, the trapped 0, is significant because of rule number 2. But how about this last 0? How about this trailing 0 right here? What do we notice about this number? Is there a decimal? No decimal. No decimal. That means that this 0 is not significant. So there are only 3 significant digits in that number. Let's see. Let's do this one. What does this negative 8 exponent mean? It means that the number 4.7, this decimal is moved 1, 2, 3, 4, 5, 6, 7, 8 times. So we can add in there 1, 2, 3, 4, 5, 6, 7 zeros in front of that 4.7 to write this out in standard notation. And what do we know about all of these leading zeros? Leading zeros are not significant. So how many significant digits are in this? Only 2. How about this one? Technically, if you were to put this out, put this to 3.01 and then move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21 times and fill in the 19 zeros, all of those zeros would be significant, right? But a lot of the time we use this scientific notation is to report an answer with the correct amount of significant figures. So even though the standard notation of this 3.01 times 10 to the 21st, which would be 301 with 19 zeros following it, we only have 3 significant figures. 3 significant figures. This is an action, 10 to the 21st, that we're doing to this. So we only determine significant figures by this first number, not by the 10 to the 21st. Hope that helps.